Hello guys, welcome back to Data Forge by Piyush. In our past videos, we have learned about different kinds of join which are used in our day-to-day data engineering life. But today I am going to cover very special kinds of join which are not used in daily basis. But as a data engineer and when you are working with the data side, they play a special role and very important role. So let's cover those two special joins which are used not in a daily basis but they play a vital role in the data engineering field. So let's go ahead. So those joins are full outer join and cross join. So let's understand it one by one with the real time examples and hands on data, how they work and what is the use case of those both. So we are going to use the same two file, employee and department file, which we have used in our past joint understanding as well. So this is how employee file looks. Employee ID, employee name, department ID and salary. This contains 6 columns, 6 rows, 6 employees data from 101 to 106. Department file that contains 4 rows, that's 4 department located at 4 different locations. So in our past joins we have seen if there was any matching keys or matching fields, then we were extracting data based on that. So suppose in this employee table we have this matching 1 2 3 2 and 5, and this department ID we have 1 2 3 and 4. So you can see 1 2 and 3 are the 3 matching department ID. So we were joining based on that and extracting the data based on that. And in those joins, when it was a match, then it threw a result. Either it's a inner join, left join, right outer join, left semi or left anti join. So all the play it was around department ID. So we are going to see now the another level of department ID use. So now what is the requirement or what is the case scenario? Suppose you want to analyze the data from both of this data frame, employee and department. So what all employees does not have any department and what all departments does not have any employee. That level of data you want to see. If there is any department null against any employee or that does not have any matching department key, then it should throw null and vice versa. If no matching department ID with the employee, then department row should throw null for that employee. So let's use this and let's extract this kind of data using our special joins. For this we need to use our full outer join. And what will be the syntax of that? Let's see. For full outer we have two data frame, df employee dot join df department. On which column? See, it is already giving you the suggestions or recommendations. You can use this. No, but not left anti. We are going to use full outer. Full outer you can write like this or you can just paste a underscore as well. And we will display this. And see, this is how our data looks like. So first you have received all department IDs. What all department IDs we have in our raw data? We had this all department IDs. This all 4 department IDs 1, 2, 3 and 4. Let's see if all those 4 has arrived. See 1, 2, 2, 3 and 4 and 5. So why this 5 department IDs when we had only this 1, 2, 3 and 4? See now. We have this fifth department ID coming from this employee table and null department ID as well. So that is the two extra department IDs we are receiving, this null and 5. Let's see how data actually looks. For this 1, 2 and 3 department ID, we have a matching rows in employee table and department table. That is why you can see it is fully populated. But for the fourth department ID, we don't have any data in the employee table, but we have data into department table. That is why the employee table rows are null while department table rows are populated. For the next department ID, fifth and null, you can see we have data under employee table but not into department. That is why this is null. See in our raw data. This is employee data set. We have data for null and fifth employee ID and fourth department ID. So these are three extra rows. Extra rows means they does not have any matching keys among both the table. While this 4 row have a matching column, that is why it has been populated from both of this table 1, 2 and 3. You can see 1, 2, 2, 3, 2. And this is 1, 2, 3, these department IDs. While this 4 and this 5 and this null and 5, these are kind of abandoned department ID. That is why they have some nullable values as well in that row. You can see these are some nullable values which has not been populated. So this is how full outer join works. So when you actually require to analyze the data in a single data frame or in a single view, that how your department and employees are connected. So you can use this full outer join. So in this full outer join, you will get three kind of rows. When you have a matching column, matching department ID, the whole row will get populated with the distinct columns. You can see no duplicated column or anything, right? All distinct values which have a matching department ID. When you don't have a matching department ID in either of the table, the other table will be null. Suppose or see, this is the employee table, so your department table is null. When you have data in a department table but not in employee, so employee data is null. So these are the three working conditions or three working results of this full outer join. Now let's move to the cross join. So cross join, that has a bit different syntax. That is a very special join. So how that works? Display df employee dot cross join df department. So this is the syntax of the cross join, and this is how cross joins data looks like. You can see you have received 24 rows. The new people who is seeing this first time, they will be really shocked to see this, or who are learning or who has started this cross join first time, they will be really shocked to see. Why? Because we have only 6 rows in our employee table and 4 rows in our department table, but you are receiving 24 rows. This is not a small number. If you have 1,000 or in a 10,000 or lakhs of rows, then you cannot believe even how your drastically or how exponentially your data will increase. So how the cross join works? Cross joins basically works like this. So let's understand with this graphical representation. Cross join help, it does not see. Here you can see cross join, we haven't used any matching column. It does not match actually with any of the column from any of the table. What it does, it joins with each and every row of another table. Suppose like this, we have an employee table 6 employees, department table 4 department. So here your first employee uh, is going to join with each and every department. So 101 is going to see this oranges line, you can see, is going to connect with 1, 2, 3 and 4, all 4 department. This bluish line is going to connect with 1, 2, 3 and 4, all this department. Likewise, your employee 3, employee 4, employee 5 and 6. So you can count the number of rows when one is connecting with 4 department, 4 row. Likewise 2, 4. Again 4 plus 4. So it has 4 rows for employee ID 1, 4 rows for employee ID 2, 4 for 3, and likewise we have till 6, till 106 employee. You can see now we have total of 24 rows. So this is how when you have data in both the table and you make the cross join, you are going to receive these many number of records. So this is a very small set of data, only 6 rows and 4 rows in 2 tables. But when you have a rows in thousands or lakhs, then it becomes a really difficult to know what amount of data you are going to actually receive. So this is very simplistic. You can see this has a total rows as a 6, while this has a total row as a 4. So if you do the multiplication of these both, then also you will receive this same results. Then also you are going to receive this same results 24. So total number of rows in one table multiplied by total number of rows in your second table is going to become the result data set of your cross join. You can see this is your multiplication between number of rows from both the tables, and it becomes 24, final result of cross join. So this cross join is basically used to make a connection and to check the proportional and possibilities and probability between employees and department, that how many employees can have, you can say one employee can have how many number of departments. So this is how you can see one employee can have 4 departments, second also can have this 4 department. So when you are doing this analysis in a probability manner, then this cross join is useful. This is not used in our day-to-day data engineering life because it gives you exponentially high number of rows. Storing, processing, and memory wise, this is really difficult to handle this number of data or this size of data. That is why this is a less used join which organization actually use. But this is used when you are doing some probability testing. So you can see, and I just sorted based on this employee ID. So employee ID 101 is connected with all the 4 department ID. 1, 2, 3, 4. Employee ID 2 is connected with 1, 2, 3, 4. 4 department. Likewise, you can see 3, 4, 5 and 6. So employee 106 is also connected with the 1, 2, 3 and 4, all 4 departments. So all of your employee tries to join with each and every row of your department. So here we are going to complete the series of join, merging the data frame, combining 2 data frames for the analysis purpose. We have learned how to combine or join 2 data frames. Either it's a union or union by name, or different kinds of join. Inner, left, right, this cross join, full outer join and all. We have learned all of this in detail. You can go in my past videos. In my past 4 or 5 videos, I have explained all of this in detail.